To isolate clove oil, Eugenol, from an emulsion of clove oil and water by liquid-liquid extraction using cyclohexane. In the previous experiment, we saw how steam distillation was used to obtain an emulsion consisting of a mixture of clove oil and water from cloves. In the second part of this experiment, we will extract the clove oil from the emulsion using a technique called liquid-liquid extraction or solvent extraction. This involves adding an organic solvent such as cyclohexane to the clove oil emulsion. Cyclohexane has the formula C6H12. The cyclohexane dissolves the oil of cloves in the emulsion but does not mix with the water. The organic solution, containing cyclohexane and dissolved oil of cloves, is then separated from the water using a separating funnel. A separating funnel is like a dropping funnel, except that the separating funnel has a stopper, but a dropping funnel has no stopper. In this experiment, we will use the separating funnel that is part of the QuickFit 27 BU kit, as this is ideal for dealing with small quantities of liquids. Pear-shaped separating funnels also exist, but these are more suitable for dealing with larger quantities of liquids. We need to start with about 50 centimeters cubed of emulsion in order to isolate a small quantity of the clove oil. The oil from the emulsion will be extracted 3 times during the experiment using 10 centimeters cubed portions of cyclohexane. Check that the top of the separating funnel is closed. When placing the liquid in a separating funnel, a beaker is always placed under the funnel in case the tap is accidentally left open or in case the tap of the funnel is leaking. Using a small plastic funnel, place 50 centimeters cubed of the clove oil emulsion in the separating funnel. Add 10 centimeters cubed of cyclohexane to the separating funnel as shown. Note that the cyclohexane, the organic layer, floats on the emulsion, the aqueous layer, since cyclohexane is less dense than water. Remove the plastic funnel from the separating funnel. Insert the glass stopper in the separating funnel. Remove the separating funnel from the clamp. Holding the stoppered separating funnel with the stopper resting against the palm of one hand, shake the separating funnel back and forth about 10 times. This stage is referred to as washing the emulsion with the organic solvent. You have now completed the first washing. Making sure that the separating funnel is not pointing at anybody, invert the funnel at an angle and open the top to release the pressure of the vaporized liquid inside the funnel. Close the top of the separating funnel. Clamp the separating funnel containing the mixture in the retort stand. Remove the stopper from the separating funnel. Allow the separating funnel to stand for a short time until the clear cyclohexane layer on top has separated from the aqueous layer underneath. Allow the bottom aqueous layer to flow into a beaker marked aqueous layer. Close the tap as soon as the organic layer comes close to the tap. Place a clean, dry conical flask marked organic layer under the separating funnel. Open the top of the separating funnel and allow the organic layer to flow into the conical flask. This organic layer contains some of the oil of cloves that have been extracted in the first washing. You must, however, repeat the washing process 2 more times in order to extract the maximum amount of oil from the emulsion. Check that the top of the separating funnel is closed. Pour the aqueous layer into the separating funnel and add a 10 cm³ portion of cyclohexane solvent to the separating funnel. Repeat the same steps to obtain the second washing. Place the conical flask labelled organic layer under the separating funnel and allow the organic layer to flow into the flask. Check that the top of the separating funnel is closed. Pour the aqueous layer into the separating funnel and add a fresh 10 cm³ of cyclohexane solvent to the separating funnel and repeat the same steps to obtain the third washing. Note that as each washing is carried out, the emulsion becomes less milky. The milky colour is caused by the tiny droplets of oil dispersed throughout the water. The emulsion becomes less milky because the oil is being extracted from the emulsion by dissolving this oil in cyclohexane. Clamp the separating funnel in a retort stand, remove the stopper of the separating funnel, and allow the 2 liquids in the separating funnel to stand until 2 clear layers separate out. Open the top of the separating funnel and allow the aqueous layer to flow into the beaker marked aqueous layer. Close the tap again. Allow the organic layer to flow into the conical flask containing the organic layers from the first 2 washings. This conical flask now contains 30 cm³ of cyclohexane containing the oil of cloves dissolved in it, plus some water that has come out of the separating funnel when the cyclohexane was being transferred from the separating funnel. This water must now be removed by adding anhydrous magnesium sulfate, which absorbs water. Anhydrous magnesium sulfate is called a drying agent. Using a spatula, add anhydrous magnesium sulfate in small quantities to the cyclohexane solution in the conical flask. Swirl the conical flask between each addition. You will notice at first that the magnesium sulfate will form clumps that stick to the sides and bottom of the flask where it comes in contact with the water present in the conical flask. Continue adding the anhydrous magnesium sulfate until the powder settles at the bottom of the flask as a fine powder without forming clumps. Do not worry about adding too much anhydrous magnesium sulfate, as this will be filtered off at a later stage. Obtain a clean, dry conical flask and find its mass. The hydrated magnesium sulfate must now be removed. Place a fluted filter paper in a clean, dry funnel and place the funnel above the conical flask whose mass you've just measured. Pour the contents of the conical flask containing the oil of cloves, the cyclohexane, and magnesium sulfate into the fluted filter paper and allow the clear cyclohexane containing the oil of cloves to flow through the filter paper and into the pre-weighed conical flask. Using 10 centimeters cubed of fresh cyclohexane solvent, wash out the conical flask containing the magnesium sulfate residue and traces of oil into the fluted filter paper. This washing with fresh cyclohexane removes any traces of oil that may be attached to the magnesium sulfate in the conical flask. The fluted filter paper helps to speed up the filtration as the surface area of the filter paper in contact with the liquid is greater than if the paper were folded in the more usual way. Note that the hydrated magnesium sulfate is retained in the filter paper. In the fume hood, place the conical flask containing the oil of clove solution on a water bath and evaporate off the volatile cyclohexane solvent. Cyclohexane has a boiling point of 81 degrees Celsius. The conical flask must not be heated directly with the hot plate, as this could boil off the clove oil as well as the cyclohexane solvent. Since cyclohexane is a flammable solvent, it must never be heated with a Bunsen burner. Note at this stage that most of the cyclohexane has boiled off. Allow the conical flask to stand overnight in the fume cupboard to allow any remaining cyclohexane to evaporate. Note that a small quantity of an oily substance is isolated at the end. The amount of oil is small as we've carried out the experiment on a small scale. This oily substance is the oil of cloves, which contains mainly eugenol as the essential ingredient, but some other oils are also present. The structure of eugenol is shown on the screen. This is what a molecular model of eugenol looks like. Note that there are 3 substituents on the benzene ring. Do not allow the oil to come in contact with your skin, as it has a burning effect on skin. Note the smell of the clove oil. Record the new mass of the conical flask and calculate the mass of oil formed. Using the results of this experiment, it is now possible to calculate the percentage of oil obtained from the cloves. A sample calculation is shown